Welcome to our channel! This is Jelay.
And this is Casey. Hey, what happened to your classroom earlier?
And it's so...
Quantum theory?
Yeah.
Wait a sec. Quantum theory is the minimum required energy for a particular physical reaction to occur. Proposed by Niel. He is the one who suggests the probability of finding an electron at a given place around the nucleus. So what is quantum number? Quantum number, it describes the atomic orbitals as well as the properties of electrons. Then, principal quantum number, it also derives as N.
So what I know about the principal quantum number is that it provides the size of the orbital and the main energy level of the electrons occupied. But can you please elaborate it more?
No problem. Principal quantum number can move by means of absorbing or emitting energy. It is the integer that Bohr used to label the orbits and energy levels of an atom. It tells us the size of the orbital. And remember that the energy gap between successive levels gets smaller as n gets larger. Azimuthal quantum number or angular momentum quantum number describes the shape of a given orbital. A value of azimuthal quantum number can indicate either an S, P, D, or F subshells. S, P, D, F. S for sharp, P for principal, D for diffuse, and F for fundamental. Magnetic quantum number indicates the number of an orbital around the nucleus. It is denoted by ml. The value of the magnetic quantum number is dependent on the value of the azimuthal quantum number. For a given value of 1, the value of ml ranges between the interval of -1 to +1. Therefore, it indirectly depends on the value of n. Like for example, S is equals to 0, P, -1, 0, +1, D, -2, -1, 0, +1, +2. Then F is -3, -2, -1, 0, +1, +2, and +3. Spin quantum number indicates the spins of the electron and may only have two possible values, which is +1/2 or -1/2. The positive value of m sub s implies an upward spin on the electron, which is also called spin up. If m sub s has a negative value, the electron in question is said to have a downward spin. Electron configuration uses symbol of the orbital and the number of electrons that occupy each orbital. It has three general rules, which is Aufbau principle, Pauli's exclusion principle, and Hund's rule.
After the given element, we should know the atomic number, for it is used to determine the electron's configuration needed. Since the given is potassium, we need to have a total of 19 electrons since it is the atomic number of it. We are following Aufbau principle. That means, in the ground state of an atom, an electron enters the orbital with lowest energy first, and subsequent electrons are fed in the order of increasing energy. For example, 1s2 shell should be filled before proceeding to 2s subshell. 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. Orbital diagram consists of axes and arrows that represents orbital and electron. The next rule that we should follow is the Pauli exclusion principle. This states that an orbital can contain a maximum of only 2 electrons with opposing spins. And the last rule is Hand's rule. The arrows with upward directions should be written first. And followed by the arrows with downward directions until the electrons are enough, which in 19. 2 plus 2 plus 6 plus 2 plus 6 plus 1 are equal to 19. So we should have 19 arrows with different directions at each axis. 4 because it is the main energy level. L is equals to 0 since S is equals to 0 as well as M sub L. While M sub S is positive 1/2 because the last box contains arrows with upward direction. Another example is B, boron. Boron's atomic number is 5. 1s2, 2p1. 2 plus 2 plus 1 is equals to 5. Same with the atomic number of boron. So we should write orbital diagram 1 for S and 3 for P. First, we should write the arrows with upward directions until we complete the electrons that are needed. 2 is the main energy level, so the value of N is equals to 2. L is equals to 1 because P is equals to 1. M sub L is equals to positive 1 since it has 3 possible value. It is the negative 1, 0, and positive 1. So we will write positive 1. Last is M sub S. M sub S is equals to positive 1/2 since the last
Arrow is upward.
Is everything clear to you now? Yes, and perfectly fine. I found it quite interesting now. And this is the end of our video tutorial about quantum theory. See you on our next video. Bye!